CAPWAP Fundamentals. So upon completion of this course, you'll be able to distinguish between the AP technologies, understand the CAPWAP protocol. Introduction to AP. A WLAN can be deployed in either of the following architecture: the AC-based AP architecture, and we call as FIT AP. Traditional independent AP architecture, we call as so this is the FAT AP. So with the deployment of WLAN and the WLAN market, FIT AP are replacing the FAT AP rapidly. FAT AP have a WAN and a LAN interface and support dynamic host configuration protocol, for short we call as DHCP, and also the DNS, MAC address current, as well as VPN. Some of the products also support the firewall feature. So this AP will be pretend like the router that we're using. So they can do almost all the feature here. They have an antenna and support all type of the version, doing the encryption, authentication, security, QoS, roaming. For the FIT AP cannot be independently configured or used. So when we're using the AP and configure as a FIT AP, you must have the controller. So in this kind of deployment, the FIT AP will just pretend like the dumb AP without any configuration. So because all the configuration is stored inside the controller. Comparison of the FAT AP and FIT APs. So the first one, the combination FIT and the AC. FIT AP are cheap and easy to manage, but the AC are expensive. FAT AP is expensive when you only compare to the FIT AP. But the best part is this one doesn't need to work with the AC. It can be work independently. Then the networking mode. The FIT AP cannot work alone and need to be maintained and managed by the controller. So when you want to change any SSID, the VLAN, or you want to swap the IP address, everything you have to done on the controller. FIT AP can be deployed on WLAN with zero configuration. So this is the advantage. When we have so many the AP deployed at the environment, so all the AP we doesn't require to configure anything. So you can just rely on the controller. Number 3, FIT AP and the AC communicate using the proprietary protocol. So they must be the product from the same vendor. AC and AP from a different vendor are not compatible with each other. So this one we have to take note. So you cannot mix with different vendor AP and the controller. Each AC manage only few AP. So this one will depend on the license, and also the maximum number of the AP they can actually support. For the FAT AP, configuration file need to be issued to each AP manually, because this FAT AP is not using the AC to do the configuration. So every single FAT AP have to configure manually. The network management system support AP deployment on a large network and management of the large number of the user. FAT AP and the MS use the standard IP layer protocol to communicate, so there's no problem with the compatibility. The NMS can be managed and maintain a large number of the AP and support the integration between wireless network and the wire broadband network. For the service, for the FIT AP can use at the layer 2 and also the layer 3 roaming. So this solution supports various voice services in addition to the data service, the QoS and security. For the FAT AP only can perform the layer 2 roaming. When go to the layer 3, the roaming will be failed. CAPWAP tunnel. So since traditional WLAN architecture cannot satisfy the demand of the large-scale networking, IETF established control and partitioning of wireless access point. So for short, we call it as a CAPWAP. This is the name for the protocol. the team to create a large-scale WLAN solution that can be connect AC and the AP. So this is the protocol used in between the controller and the AP access point. So here I have 4 reference protocol for the CAPWAP protocol. So LWAP, LWAPP, the standard is RFC 5412. So this is proprietary protocol by the Cisco. Okay, so this one is giving the comprehensive description of the detection, security, and the system management manner to support the spread MAC and the local MAC model. AC and AP are connected on layer 2 or layer 3 network. On the layer 2, the LWAP packet are transmitted in the Ethernet frame. On the layer 3, it will transmit in the UDP frame. The encryption. This protocol only do the encryption on the signaling. Okay, they're using the high-level encryption, AES CCM, but to the data, they never do anything. Okay, there's no encryptor for the data. SLAPP. Okay, this is belong to the Aruba. So they support 2 local MAC mechanisms, the bridging and the tunneling. Support direct connection, layer 2 connection, and also the layer 3 connection. They use the mature technologies and the standard to build tunnel and use GRE for the data communication. So compared to the previous one, the Cisco, the LWAP, this one they got doing the encryption on the signaling and also the data link, both using the DTRS to perform the encryption. CTP, defined by Siemens. Use the extended SNMP to realize configuration and management of WTP. So CTP control packet are used control SDA connection status and WTP configuration and status. So this is basically for you to easy to manage using this kind of the proprietary protocol. Okay, using the SNMP. Define the authentication mechanism and the serial of the encryption rule based on the AES CCM, but the rule is still need to be optimization. And the last, YCAP, okay, defined by the Panasonic. Define the AC detection mechanism, including the AC to the AC performance negotiation. Define the QoS parameter. Okay, so this is the feature for this protocol. So the protocol recommend the IPsec and the EAP security standard, but do not specify the implementation method. The CAPWAP origin, so you're going to take out all the advantage, the better feature from the different protocol. So it will take some of the feature in the SLAP-P. The highlight of SLAP-P is the DTRS technology, which is highly applied in the industry. And the LWAP, okay, this is the full name for the LWAP, has a complete protocol architecture and defined detailed packet structure and the multiple control methods. Then the last two is the CTP and the YCAP. So they can be satisfied the demand of centralized WLAN architecture. CAPWAP protocol is used for the interconnection between AP and AC. It enables an AP manage connect the AP in the centralized manner. CAPWAP protocol provides the following function: automatic AC discovery and operation, maintenance of the AP and the AC state machine, the AP management and the service configuration delivery, and the SDA data forwarding through the CAPWAP tunnel. So there's two different forwarding modes for the inside the AC. So we can configure in the direct forwarding or the tunnel forwarding. In the direct forwarding, so you notice in the picture here, they were showing one blue color tunnel. Okay, so this is a CAPWAP tunnel. The red color dot is referred to the data, the user data. When the user want to forward the data, or maybe they want to access to the network, the internet. So in the direct forwarding mode, they can go directly to the gateway and go out to the network directly. So this is called the direct forwarding. In the tunnel forwarding, which is this one, for all the user data must using this tunnel. So all the data frame is sent back into the tunnel here, returned back to the controller, and let the controller to forward out the data to the network. So this is called the tunnel forwarding. So right here they have the advantage and the disadvantage compared with this direct and the tunnel forwarding. The advantage: service data does not need to forward by an AC, improving the packet forwarding efficiency and reducing the burden on the AC, because all the data can just go directly without passing through the AC anymore, so they can able to have the better performance. Okay, what is the disadvantage? The service data is difficult to manage and the control in the centralized manner. So right now the packet is bypass the AC, so that means right now you can't able to using the controller to control the user data, so you have to rely on the firewall. Then the next, the tunnel forwarding. What is the advantage? The AC forward all the data packet, ensuring the security and facilitating centralized management and control. So they can centrally manage all the AP protocol and also including the data frame sent by our user. Service data must be forwarded by an AC. Reduce the packet forwarding efficiency and burdening the AC. So this is a problem here, because when we're using the tunnel forwarding, all the traffic have to go back to the AC before you going out to the network. And this is the packet format. So they have two different packet format. First is called control packet, and the next is a data packet. Data packet is belong to the user, like we access to the network. All our packet is this data packet. Control packet will be used by the AP. So both of them using different type of the port number, the UDP port. Okay, so this is how does it look like for the control packet. Okay, and this is for the data packet. AP online process. Discovery of the feed AP by AC process. Is there a pre-configuration AC IP address in the list? Okay, so this is happening to the AP. When the AP will already boot up, and then the first thing they're going to check, do you have any pre-configured static IP to make the AP find the controller? If yes, then the AP will associate with the AC using the specific IP address. So once form the connection, then end. Okay, they will establish the link. If there no, mean we have never statically configured any IP address, then the AP will run the auto discovery to send as a broadcast. So send a broadcast and try to discover the AC. So when successful associate with the controller, then they will form the CAPWAP tunnel. Okay, this is a dynamic discovery. Okay, this is a complete process. Okay, you require the AP, DHCP server, DNS, and also the controller. AP will try to get the IP address, because for all the IP device, if you want to form the connection, the first thing you require is the IP address. Then once you already get the IP address, the next step, if in the same local network they have the DNS server, so you try to find the AC IP address from the DNS server. If they have no DNS server can able to get to know where is the AC, no problem. The AP will still able to send a broadcast and find the controller as long as they belong to the same network. Okay, so after the AC respond back to the AP, then they will form the CAPWAP tunnel. So the solution of the network exception. So if the DHCP screen on the live network does not support the option 43 or option 15, take the following measure. Enable the AP to discover the AC using the CAPWAP if they are connected through the layer 2. For the layer 2 network, it will be very simple. As long as you can using the AP ping to the AC, okay, I mean it's only on the layer 2 network. Okay, they can form the interconnection. So they can always running the auto discovery to form the CAPWAP tunnel. But on the layer 3, when the AC and the AP belong to two different subnet, two different VLAN, so on the layer 3, you have to do some configuration. So use an AC as a DHCP server to allocate the IP address to the AP. Okay, so this method is recommended because if the AC is the DHCP server, when they allocate the IP address to the AP, when the AP can get this IP address, right, this means they can always file the controller. Or else, you have to touch on the option 43. Okay, this is happening for those of the DHCP server. Okay, you notice have some of the field, they did mention option 43. The option 43 is one of the settings for you to configure the IP address of the controller. So this applies for the layer 3 network when the AP and controller belong to two different VLAN, so you have to touch on the option 43. So this is a process for them to establish the CAPWAP tunnel. So let's begin from our first one. The AP, DHCP server. So starting the AP, we're going to send the discovery message. Okay, try to find the DHCP server. So this packet is belong to the broadcast. So when the DHCP receives the discovery, it will offer the IP address to the AP. Then the AP will send the request. At last, the server will confirm with the AP. Okay, send the acknowledge. So when this process is done, now my AP got the IP address. So the next thing, you're going to send the discovery request. You try to send the request to find the controller. So when the controller is at the same network, you're going to send the response. So this one is just optional because it depends on the configuration, whether we got enable the DTLS or not. So once you establish enable the DTLS, yes, they're going to form the DTLS first. Okay, after the link is already established, then you start to send a join request. So the AP is going to inform to the controller, I want to join the CAPWAP tunnel. Then finally now they can start to sharing the image data information. The controller can using the configuration status, okay, to share the information between the AP and the AC. For the data check, so the AP will periodically send the change event request. Okay, so this is AC how the way to receive all the information and also the log. In the meantime, AP will send the keep alive also to make sure the CAPWAP tunnel is still established. The AP will keep sending the equal request to the AC to make sure the connections. Okay, this is something like the ping request and the ping reply. Okay, so this is one of the infrastructure. So two AP deployed at the region 101. The AP number 3, number 4 belong to the AP region 102. So they are the two separated regions. And the configuration here, you're going to put the AP1 and the AP number 2 in the VLAN 11. Okay, these two is belong to the VLAN 12. Okay, this is 11. Okay, let's look at this. So this is a call switch. We have the VLAN IP address 11, 12, 100, 101, and 102. So basically, this is the gateway for everyone. Okay, so even for the AP, they also have to go through to the gateway here. The IP address for the controller only have okay, this is a source IP address 10.100.100. 100.100 means this is the VLAN 100. Okay, VLAN 100. And also included the VLAN 101 and VLAN 102. Okay, so the gateway is right here, and this is router. My controller is right here. My controller have the VLAN 100, 101, and 102. Okay, now when the PC is trying to connect the Wi-Fi, so they try to look for this SSID. I want to connect to this SSID, the Huawei 101. So it's broadcast from these two AP in the VLAN 11. So my client sending out the DHCP information will be look like this. The source IP address, no information because I don't know what's my IP yet. DIP, destination IP address. I also didn't know where is my DHCP server, so I will send this in as a broadcast. Okay, so are you going to send to the AP here? So when the packet entering to the AP and come out from the AP, so they have a two different process. So the DHCP request in the CAPWAP tunnel. So right now I'm running the CAPWAP forwarding mode. The tunnel forwarding mode. So right now my AP and the controller, they establish with the tunnel. Okay, they have a CAPWAP tunnel connecting. So all the user have to using this CAPWAP tunnel return back to the controller before you can go to the DHCP server. So the information inside the tunnel here will be look like this. So from the outside the view, you'll notice the source IP address is the AP number 1, 10.1.11.101. Okay, this is my AP. AP number 1. And my destination IP address is go to the 10.1.100.100. This is a controller. Okay, this is a controller. So the connection is between the AP and the controller. So the user data is sent through here from the user using the tunnel all the way back to the controller. Okay, of course the information here is 5247. I did mention earlier on, 5247 is for the user data. 5246 is for the those of the AP controlling packet. Now the AC received the DHCP request. So it's going to check. Okay, right now you connect to the SSID. This one, the Huawei 101. Okay, you connect to this Huawei 101 and I will know. Okay, when you connect to this SSID, I'll know you actually want to get the VLAN 101 IP address. And I'm going to help you to send this one to the DHCP server. Then the DHCP server look at your header here. You are belong to the VLAN 101. Okay, so I will need to base on your VLAN and offer you the IP address. Okay, now the DHCP offer the IP address. This is your IP address. If you want to go online, so this is the IP address I offer to you. Okay, this is your subnet mask, the gateway. Okay, the gateway will be right here. Okay, this is my switch gateway. Of course, we can configure it on the server here if you want to change the gateway. The DHCP server create the DHCP offer. It will send to the controller first because only the controller know where is this user. The AC is going to put the DHCP offer inside its own tunnel because this offer have to using the tunnel return back to the AP here. Okay, to send back. So after the AP receive this DHCP offer through the tunnel, so you're going to remove the CAPWAP information and send the DHCP offer to the user. So this is how our PC get the IP address. So this is a summary here. Okay, I do some introduce about the fat AP, and the process of the CAPWAP tunnel establishment.